a minute or so away from starting, and hopefully this will give you time to get settled and organise yourselves, and then in less than a minute or so we will start our broadcast properly.
This video is private. This video is private.
Settled and organise yourselves, and then in less than a minute or so we will start our broadcast.
I'm going to log into Gmail first.
Okay, if you've joined us now, we're just sorting out the last minute technical issues to make sure that everyone is working, and we'll do introductions in a second. Are we good? Good. Right, we will start. Just as a quick introduction, my name is Chris Daniels. I work at Hybrid Air Vehicles, and welcome to this webinar on how to build a heavy lift airship for the Schools Aerospace Challenge. We've been helping the Schools Aerospace Challenge on this, obviously, because we are pretty much the UK, if not the world's leaders on building aircraft, and particularly airships, and particularly innovative hybrid aircraft. Just in terms of admin for today, if you're on YouTube, please use Twitter, drop us a note if you've got any questions throughout this. If you're on Google Hangouts, go onto the Google chat and drop us questions whenever you want. We'll try and get to them either immediately or later on. And if you're watching this recorded, then please send us an email and we will respond in to any questions that come in. And the email to use is info@hybridairvehicles.net. info@hybridairvehicles.net. Okay, what I'm going to do now is probably 10 minutes of quick introduction to how to build an airship, and hopefully we'll get some questions and other items coming through. So, how to make an airship? The very easy go. So here is one airship. So starting point is get a material that retains a lifting gas, and a lifting gas is anything that's lighter than air, and through Archimedes' principle, the weight of fluid displaced gives you the upthrust or buoyancy. That's what gives it the lift. That's the starting point. You then need to give it some power, so put some engines on board of some description, and where you place them, kind of an interesting debate and discussion. And then you need to have some control that allows you to control the engines, control the power, control where they're pointing to give you some steerability. So all this technology is over 150 years old. Airships have been around for quite a long time. However, there's a lot of modern technology goes into the modern version of airships. What I want to do is just do a brief history lesson, because our founder, he was looking at this whole area in the 1970s, and there hadn't been a whole load of development in airships since the 1930s. And he sought out the expert in the field, who was a chap called Sir Barnes Wallis. You may have heard of him because he was the man who invented the bouncing bomb in the Second World War. But before that, in the late 1920s, early 1930s, he was working on the state-of-the-art British airship, and he effectively led the team that built the R100, which was a huge airship, the biggest airship Britain's ever built, and one of the biggest ever in the world, that ended up flying to Canada and back and doing some quite amazing things. So our hero, Roger, the founder of this company, met with Barnes-Wallis in the 1970s and said, what are the issues? And he came up with 5 things, and I'll go through those 5 things. So first of all, better retention of the lifting gas. It is inert helium, not flammable hydrogen. You also need improved fabric properties for the envelope or the hull material, so allowing non-rigid airships to increase in size. So all the early day airships were rigid internal structure, normally duraluminium, that gave it its shape. The modern airships, like ourselves, like the Goodyear Blimp, they don't have any internal structure. You save all that weight, and they're pressure stabilized by the helium inside. So in terms of this, there is nothing that is inside that is a rigid structure that's holding that. And we've got the very latest strong materials that actually came out of America's Cup sailing technology, the same sail material that didn't distort, didn't change shape no matter what the conditions. So this is the same. So the material here doesn't distort, it doesn't change shape, and it will therefore can sort of hold the shape of the aircraft without having internal structure. So that's an important innovation, and it makes it a lot lighter. How big non-rigid airships can get, I don't know, but a lot bigger than this one. And this is 92 meters long and is the largest aircraft in the world at the moment of any sort. The next thing that Barnes-Wallis suggested was utilization of composites and plastics to reduce weight and hence improve the payload capacity. So again, modern hybrid aircraft and airships use carbon composites throughout, so the same as the sort of Bradley Wiggins high-tech bicycles, and just the latest, very latest materials as a weight saving and as something that's very strong. And then the 4th point was about developing a full authority vector thrust system to aid in takeoff and landing and maneuverability. What that means in layman's terms is the ability to rotate the engines or rotate the thrust from the engine so it can point down or point up. And basically that allows you to maneuver at low speeds, but also it allows you to hover, to vertically take off and vertically land. And it really helps with carrying things, and I'll talk about that in a little bit, about the ballast and how it affects and helps that. And finally, he talks about improving the flight control systems to give the pilot better control of the aircraft. So in days gone by, there were sort of big heavy wheels, and you're sort of literally moving these giant rudders on the fins, and you had cables doing all that. That was a lot of weight and a lot of manpower needed just to do that job. Now it's all fly-by-light, really compact and very lightweight, as well as using light systems to control everything going on the aircraft. So those were Barnes-Wallis's innovations. Roger Monk spent his whole life, sadly passed away in 2010, getting those innovations into modern aircraft, and the result is the Airlander 10, which is our hybrid aircraft. So that's the sort of I guess the starting point of thinking about designing a heavy lift airship. If we think about the particular problems of a heavy lift airship rather than just an airship, one of the key issues is about getting weight on board and unloading it, and actually just dealing with that issue. And a lot of people have put a lot of thought into that. It's an issue, it's a problem. So the starting point is old airships floated, and so you would literally pretty much hold them onto the ground with a whole bunch of ropes and a lot of people doing that job, and then you'd load on the weight, whether that was passengers, whether it was cargo, whether it was whatever, and you'd have a kind of ballasting system, which may be water, maybe sand, and you'd offload one lot of weight and add another lot of weight, and then you'd eventually let go of the ropes and let the airship go up into the air. And then you've got a massively efficient way of flying, but with quite a lot of ground handling issues. So people have said, well, that's fine, we can do better. And there's been a number of systems at looking at how to do better. So you can play about with the ballasting, you can be clever about how you bring ballast on, bring ballast off, and in effect replacing the weight of water or whatever the other ballast is with the cargo or the goods that you're trying to carry in quite a clever way. That's one solution. The solution that we've gone for is the hybrid aircraft solution. So what we've done is we've created an airplane wing mixed with an airship. So we then can fly or land and take off being a bit heavier than air. So we'll always naturally float to the ground. That gives us controllability, allows us to put things on and off. And then with the thrust and with the airflow over the wing shape like that, that creates lift, as in addition to all the efficiencies we get of having a aircraft filled with helium. But that lift gives it the extra lift needed to carry that heavy weight that we've just put on board. So that's another solution. Third solution, which we also use, is vector thrust, which I mentioned previously, and that's the ability to direct the airflow downwards or upwards, and we can get plus or minus 25% of our lift via that method. And there's two ways. You actually turn the engines, which on the front of our aircraft, and probably turn that around, you can see kind of roughly the attachment point just at the bottom, right there. Yeah, just there. That's where the front engines go. They're being tested at the moment at the back of the hangar. You can probably see way down the end, somewhere down there. And the engines turning on the front will force air down, or if we're unloading or putting freight on, they can force the aircraft further onto the ground if it's particularly light. So that's also a useful ability. And we also have on all the engines, the two at the back as well as the two at the front, that can do exactly the same job and force the airflow, a bit like a Harrier jump jet. So that's another solution to the problem. A third solution to the is a thing called compressed helium, and this is a technology. Actually, it's just been patented in the US by a different company, and they think they've got of compressing the helium and therefore reducing the amount of lifting gas and therefore reducing the buoyancy, and then reversing that process to increase the buoyancy and get up. Theoretically, it works. We've looked at it a lot, and there's a lot of kind of commercial issues about just how big those compressors need to be and how strong those bags need to be to make this commercially viable. But we'll watch and see. It's an interesting technology. So that's really, I think, the main challenges. I've been chatting for about 15 minutes to Twitter and see if we've got anything coming through. So I'll give it probably another 30 seconds or a minute. If there's any questions coming through live, we will answer them now. And if not, we'll just wait for the email questions to come in, and hope that you enjoyed this very, very brief introduction into how to make a heavy lift aircraft, brought to you by Airvehicles. Okay, I think we're going to wrap up at that point then. Hope you all enjoyed this, and if you're watching this on YouTube subsequently, please drop us a note at info@hybridairvehicles.net, and we look forward to hearing from you, and good luck with the competition. Thank you.